Hi guys, and welcome to day 2 of talking about acids and bases. So today we're going to talk about the hydronium ion and acidity. So first of all, what you need to know is that water will actually do something called self-ionize. And it sounds kind of crazy to think about it, but water, and this reaction kind of shows how it's reacting with itself, but in very, very small proportions. Water will actually ionize itself, basically meaning it's dissolving in itself, and produce the hydronium ion and the hydroxide ion. Now these concentrations are extremely low, but this is what pH is actually based on. So if we look at what this says up here, the concentration of the hydronium ion is actually 1 × 10⁻⁷. Hopefully you guys can actually see that. And the same thing for the concentration of the hydroxide ion, 1 × 10⁻⁷. So what we see is that because for every 1 water molecule that gets broken, we're creating equal proportions of hydronium and hydroxide ions. So it makes sense that those two concentrations are similar to each other. Now, what is 1 × 10⁻⁷? I mean, it's a really small number. So that, to be written out, would actually be something like 0.1234561 molar, or that many moles per 1 liter of water. And so that is a very, very small concentration. So what we see is that in a neutral solution, which we know water is a neutral solution, the hydronium and the hydroxide ions, their concentration, so that's what this little box, little bracket actually means, is the concentration. So those two concentrations are actually equal. So that's what gives water a pH of 7. And it's not actually a coincidence that this 1 × 10⁻⁷ also corresponds to the pH being equal to 7. So we're going to talk about that a little bit later. So, not to kind of throw too much at you, but the ion product constant for water, so it's this Kw, right? So that's, this is just the big fancy name for Kw. The product of the concentrations of both the I say hydrogen ions, but I meant hydronium ions times the concentration of the hydroxide ion. So if you get your calculator out and you take 1 × 10⁻⁷ and you multiply it by 1 × 10⁻⁷, you will get what Kw is. So if we do that, we find out that Kw is actually equal to 1 × 10⁻⁴. This is a really important number. We're going to be using this number whenever we want to calculate the concentration of either one of these ions. So if we're given the concentration of the hydroxide and we want to find the concentration of the hydronium ion using simple algebra, and don't worry about Kw over here, you would just take, if you knew that this was 1 × 10⁻⁴, for example, simple algebra, we would take, to solve for the hydronium ion concentration, 1 × 10⁻⁴ and divide it by 1 × 10⁻⁴. And then that would give us the hydronium ion concentration, which in this case would then be 1 × 10⁻�11. So there we go. Now, if we want to talk about whether or not a solution is acidic or basic, it just depends on whether or not the concentration of either the hydronium or the hydroxide ion is greater than or less than 1 × 10⁻⁷. So what we would see up here then, if this was 1 × 10⁻�11, this number would actually be less than 1 × 10⁻⁷. And you're like, but wait, 11 is bigger than 7. Yeah, but that's also, we're dealing with negative exponents. that would be the concentration of the hydronium ion, and the hydroxide ion would be, so which one of these numbers is actually bigger? Well, it turns out that the one with the smallest negative exponent is actually a higher concentration. So this solution, if these were the concentrations of these two ions, this would actually be considered a basic or alkaline solution, a solution in which the hydronium ion concentration is less than the hydroxide ion concentration, or hydronium ion is less than 1 times 10 to the minus 7th. Okay, so that's what we're going to be working with here in today's lesson. So we've got a couple of examples that we can go through, and you may want to get out your calculators so that way you can do some of these calculations along with me. Let me grab mine real quick. So if we look at example 1, it says if the hydronium ion concentration in a solution is 1 times 10 to the minus 5th, what is the solution? Is the solution acidic, basic, or neutral? And what is the hydroxide ion concentration? So if we first answer the question, 1 times 10 to the minus 5th, is that greater than or less than 1 times 10 to the minus 7th? And it turns out that this is actually greater. So we know right away that this is going to be an acidic solution. So let's answer the second part of the question. What is the hydroxide ion concentration? So once again, if we take the hydronium ion concentration times the hydroxide ion concentration, and we set that equal to the product, the ion product constant, or Kw, 1 times 10 to the minus 14th. And we know from this that our hydronium ion concentration is 1 times 10 to the minus 5th. So I'm going to go ahead and erase this and put that into my equation. Now I need to solve for the hydroxide ion concentration. So again, simple algebra. I'm going to divide both sides by 1 times 10 to the minus 5th. And we get these two numbers canceling out. So again, getting our calculator out, make sure that you're actually not only entering this correctly, but getting the right answer. So I've got 1, not used to this calculator, times 10, oops, 1 times 10 to the minus 14th. And then I'm going to divide that by 1 times 10 to the minus 5th. And I think this calculator has to have brackets in there. Okay, so we should get 1 times 10 to the minus 9th. And again, we do need to keep our units on here as well. And so we have units of molarity. So that's what concentrations are actually equal to. Okay, so again, we should go ahead and do all of the rest of these. It says classify each solution as acidic, basic, or neutral. So be careful as far as what you're given out in front. And notice that we don't always have to have 1 times 10 to the whatever. We can actually have other numbers, and they don't even have to be whole numbers. They can actually be like 6.3 or 7.9. So sometimes you definitely need your calculator. But in any case, this is going to be much less, so this is going to be a basic solution. our hydroxide ion concentration is greater than 1 times 10 to the minus 7th. So you're like, well, maybe that's acidic, but we're talking about the hydroxide ion concentration. So this is also going to be a basic solution. Letter C. Oh, well, this is interesting. So is 2 times 10 to the minus 7th greater than or less than 1 times 10 to the minus 7th? And it turns out it is greater, so this is acidic. And in letter D, it's actually equal to 1 times 10 to the minus 7th, so this is a neutral solution. And in our last example, example 3, if the hydroxide ion concentration of an aqueous solution is 1 times 10 to the minus 3rd, what is the hydronium ion concentration? And is it acidic, basic, or neutral? So again, this hydroxide ion concentration is greater than 1 times 10 to the minus 7th, so this is going to be a basic solution. And if we type this in, again, we're looking for the hydronium ion concentration, and we're going to multiply that by 1 times 10 to the minus 3rd, and set that equal to 1 times 10 to the minus 14th, I get 1 times 10 to the minus 11th molar. And that is also my answer. Okay, if this doesn't make sense, please make sure you guys are sending me messages in Canvas. And that is it for today, besides working on some of the homework that I'm going to assign. So thank you.